Hello everyone, and welcome to A4 Technologies Systems Community Program once again. And today's topic is going to be storage fundamentals. Just to give you a brief or quickly touch base, we have covered so far regarding the basics of Linux and systems, and then we covered some topics like file systems, object storage, SAN, NAS, etc. And right now it's the continuation of the storage with storage fundamentals. Somebody might ask that why is the storage fundamentals being taken at the end? But trust me, this is going to make more logical sense once you hear it. Today I have another host with me joining, who is going to deliver is Sachin. Hi Sachin.
Hello.
So basically this is going to touch base upon the hardware part of the things, and you can connect the dots and see a bigger picture and better picture in the whole continued series today. So with that, I'll hand it over to Sachin. Thank you.
Thanks a lot, Pranav. So let's get started, everyone. Why storage fundamentals, right? We started off our community program with Linux fundamental. That is a prerequisite that we have. Correct. We started off everything with Linux-based system, and then we moved on to file systems and network file system, and of course object storage. Now, where is all this leading? It's leading to the storage fundamental parts, right? What exactly is the storage? So let's start this session with what we have here. Okay, so we'll talk about what exactly the storage is, right? And then we'll cover some of the conceptual storage level, something like NAS, SAN, and NAS. Those are the most common questions that you'll hear across the board, right? But then predominantly we will look at what exactly NAS is about, what are the benefits, different arrays that we have. Of course, a very high level architecture for a NAS array. A specific area that we will further dig into is the scale out NAS array, and of course the advantages of the arrays that it provides, right? And of course resources and assignment as we typically follow our model. So what exactly is the storage, right? When we talk about data, we started talking about data when we touched upon the file system session, right? And this data is nothing but kind of information that you want to actually store at the device that you will use to store this data or the information is definitely a storage device, right? That's the typical definition that you will hear across the board. Now, there are many different types of storages that we have, and the most common devices that you have or must have used are your hard drives of laptop or PCs, right? Your removable memory cards, or on a server level, you have magnetic tapes, right? Those are connected to the servers. So a very broad level category, of course, are again magnetic storages, something like hard disk or a tape drive, versus optical storages, something like a Blu-ray or a DVD or a CD. Those you have handled quite a bit, right? And then of course there is advanced level of storage devices which are flash based, and those are most in common right now through memory cards and USBs, right? And of course the SSD drives that now you must have started seeing around being used in laptops or PCs or even enterprise level storage devices. When we talk about enterprise, right? So this information or the data that is stored into the storage system, and those systems are called arrays. Okay, array is nothing but more number of storage devices stacked into one or more racks. Okay, how those are being used, we will look at those things. And of course, this is a hardware component that is mostly that mostly consists of homogeneous or heterogeneous devices within a cabinet. Okay, let's move on to the next part. When we initially talked about storage, right, there are three fundamental legacy uh, storages that we have seen across the board. And the first one is the simplest one, uh, which is a direct attached storage, right? A very simple architecture on your screen. It's nothing but your storage directly connected to the, right? And that's why it is a directly attached storage. So if you see the storage devices, one or many that are directly connected to the server, and then those servers providing services to the external world through a LAN or a WAN to clients, right? Now, what are the limitations? There are quite a few limitations. The biggest limitation is that it has a very high cost and a high maintenance, right? Because it is managed to a single server. Of course, it adds management overhead because you need to manage those services on each individual server. Scaling would be another problem, and of course, the time for maintenance would also be there. Of course, there are a few advantages, such as it is a faster and quicker way of storing data, right? And it will be manageable as long as it is within the limits that you want to manage. But it has more limitations than the advantages. So, what is the next level? The next level that we have here is called a SAN. Now, this is a little different than a directly attached storage.
So,
right?
Sachin, uh,
Yeah,
can,
Pranav.
can you go back to the earlier diagram? There was.
Yeah.
So here, when you said directly attached storage and you talked about the servers directly connected to the devices, you are talking about only the right part of the diagram, just to
Correct.
clarify. Yeah.
Yes,
So that
absolutely.
audience is clear about it.
Yeah, right. So if you look at the storage devices that are directly connected to storage, that's what we're talking about here. This other picture is where we are presenting that data service to the end user through clients. Okay, and that is over the network. Yeah, good question, Pranav. And yes, that's a clarification that it's only the right side of the diagram. All right, let's move back to the storage area network, right, which is called SAN. Now, if you look at the diagram here, what you see here is a pool of block storage devices, right? Those are typically, block storage arrays and that are connected through, specific protocols with the servers. And that what it forms as SAN, right? Again, advantage here is that we are assigning storage devices from a storage pool. That means the storage devices are shared across the servers, right? So that more than one server can access the storage pool, and that is using different protocols. We'll come to which protocols that typically use, but something like iCASI, right, or a CASI port. Now, again, what is the limitation? Of course, the limitation is again that you need to add the management of this storage devices or storage pool. Plus, scalability would be limited. It is better than DAS, but of course it's limited. Why? Because you can add more storage devices to the pool, but when it comes to management part, we need to provision those devices, right? Of course, it allows you to improve the utilization across the board, right? Most of the storage devices, and we have a centralized management for the storage, correct? But again, there is even if we build the high availability across the SAN, there would be some downtime when you want to do the maintenance. There are a few limitations that will be across the board. And that brings us to the most evolved part of the storage, and that you have seen a lot is your file system. Well, now this is a highly advanced storage system, and a fundamental difference between SAN and NAS is that SAN is a block storage device. What that means is it provides you only block device, does not give you any facilities where a file system would be available. However, in case of NAS, which is your network attached storage, which is predominantly a file-based storage system, what is important here is that it provides you a file level sharing it over IP network, right? And that's why these systems are typically called as filers. And you can use different protocols. And here we come to our network file system protocol, something as NFS and SMB, which we have seen in the earlier session. And that's why, just a logical point why we are covering this session now, because when you put together all the session that we have conducted and connect the dots, you will see that this is how your NAS system is evolved, right? You will be able to use these network level protocols while working on NAS, right? Again, there are quite a few advantages, and we'll talk about those advantages at length. What exactly those benefits, right? A very high level is, it's a very simplified management, because the arrays that we're talking about has CLI as well as UI management for file system, network connection, and various features. It allows you to manage your hardware and the code so that you can manage it better, you can upgrade it, you can put the patches. It provides you better performance, right? Because it can be a hybrid storage. It can use flash cache, and it can use different mechanisms in the background to improve the performance. Of course, availability would be better again, because you can form a NAS cluster, a highly available storage system, right, with multiple controllers, and provide you fault tolerance. And of course, there are a lot of advanced features that comes along with the file system that NAS provide. And those are your RAID protection, snapshot, backup, disaster recovery, encryption, compression, deduplication, so on and so forth. So we'll take a look at a few of the benefits in depth again. Let's move on to the next section, and which talks about, what are the types of NAS arrays that we have. Uh, I see a hand being raised. So is there a question coming?
No.
Okay, I guess not. Okay, all right. So let's continue with the types of arrays that we have. So we have predominantly three different types. So the first one is your traditional NAS array, which is nothing but one or more cabinet with multiple drives, right? And the limitations are, it's only providing a file-based sharing, okay, using your standard NFS and CIFS protocol. It comes as a standalone storage, like I mentioned, and it's only through the file sharing protocol that it's available, right? Of course, it can be used across the board, small, medium, or large organization. A unified NAS array, which is more of a combination of your traditional NAS array with your block level SAN arrays. And what's the benefit is that it provides you a multi-protocol support, which is both file-based access as well as block-based access, right? It will contain, of course, definitely a separate drive pools for both block and file storage. And we need a management layer which will keep the IO for these two different things separate. But of course, it comes with the unique, approach, and it allows you to increase the performance overall. This is typically used across small and medium organization, and the reason for that is if they don't want to invest in two different types of storage arrays, then they typically go for the unified NAS arrays, right? And the third type that we have here is your scale out NAS array. This is exactly what we would be focusing more on. What is scale out? We will talk at length again in the next couple of slides. The benefit of a scale out array is, of course, it's increased scalability, and this is where it used across the board for big cloud and big data environment. It allows you to use all the features that is provided with traditional and unified arrays, which is basically your NFS and SMB protocols over Ethernet. It gives you the horizontal scalability, right? Something like when you talk about scaling up, right, which is more of adding more resources to the single node, right? So for example, you're running an application on a single host, and if you add more memory or CPU, it will allow you to scale up your storage. Uh, Now, what is scale out is basically if you have capability to add more such host or more nodes to the which will have its own CPU memory and storage resources. That would be your scale out. We'll talk about that. And such clusters are called scale out NAS clusters, right? It provides a very unique feature, which is your single file system, a global namespace, and that will allow you to, balance out your data placement at the backend and increase the IO operations in parallel, right? These are called distributed and cluster aware data systems because it's distributed across the board. All right. I'm seeing some messages in the chat.
Yeah.
Okay. All right. So, yeah, use question and answer if you have any questions. All right, let's move to the next one. So this is what we're talking about when we typically talk about a very high level array architecture. Like I mentioned before, you have a very basic scale up architecture and then you have a scale out. So if you look at this high level diagram, you see a single node or a single controller based architecture which is allow you to scale up its resources. That means you can add more CPU memory or storage devices to a single node. But when you talk about, but again, that has its own limitations because there's a upper ceiling. You cannot go beyond certain number of disks, certain number of CPUs or the memory in a single controller. And this will have a limitation when you try to scale it up. And a solution for that is your scale out architecture where you have more such node where each node will be capable of providing you the resources and the services. And if you form a cluster of such nodes to manage under single global namespace, you would be able to use this scale out architecture, and based on the requirement, you can keep on adding the nodes which has its own CPU memory and other storage resources. That's where the advantage of scale out NAS array comes into picture. Well, a deep dive into the scale out NAS array. Internally, this is how it would typically look like when you have multiple nodes to form a cluster. You know, it will have its own separate network to talk to each other, right? That is something called your management network. And of course, it will have external switch to connect to each node, right? And it will also allow you to redirect your IO and provide different levels of network for management IO as well as the public network for the end user IO, right? Like we discussed before, there are many advantages. Why? Because it provides you an efficient capacity planning. So you're using multiple nodes, multiple storages, and it provides you the additional capability. It provides you a better performance and of course a easy and simplified disk management. And like we discussed before, the advanced features that come with the file system level, right, such as backup, disaster recovery, snapshot, provisioning, deduplication, compression, high availability, and of course the OS and hypervisor level offloads, right? And of course the reliability aspect with multiple controllers. So that's what is a scale out NAS arrays. Right. So that brings us to the last portion, which is the resources part. And these are few of the resources that we have referred to, of course, and these are easily available over internet. So feel free to refer to these resources which has much more information that we have covered right now in our session. And of course, if you have any questions, queries, feel free to drop us an email and we'll get back to you with those details. So few sites for storage basics, and there are a few sites which is more details about what exactly those SAN NAS areas are. Okay, what is a chat session? Right. So the question here is a SAN uses a fiber channel and block level protocols like ICASI or CASI level, right? Isn't it faster than NAS? Yes, of course it is faster, but like we mentioned, the limitations of SAN are you cannot scale out your SAN devices, right? And it would be limited, of course, over network, and the network capability like IO performance and latency would play a big role when you use the SAN devices. Whereas when you talk about the cloud infrastructure nowadays, right, the cloud gateways, the cloud storage, you need something more than that. You need two things. One is your file level protocols with advanced capability, plus you need the performance, right? And that's where this unified array comes into picture, where on one side it allows user to use the protocols such as NFS, SMB, object storage S3, right? So that you can use object storage over cloud and other hypervisors, versus in the backend it uses a SAN storage arrays with faster access to the data. So that's where the storage evolution has come to. I hope that answered the question. That yes, SAN is of course faster over NAS, but when we look at the distributed file system and distributed storage, NAS has its own advantage. Okay. All right. Back to the resources. When we talk about this appliances, right? Of course, it will be difficult to have a NAS appliance on your own, right? So what is the solution? The solution is a free to GPL license-based NAS system, which is FreeNAS. Right here, freenas.org, and that allows you to simulate the NAS system. So it has a very basic requirement. So do visit this site, which is freenas.org, which will allow you to configure your known NAS appliance. So this is a free GPL, the general public license based operating system, which allows you to create a NAS level environment. Okay, so there's a link for the user guide which will allow you to install and configure. And that's where Pranav mentioned earlier that why we are putting this session at the last, because here you will need first a Linux box, second, the understanding of file system, third, different protocols like NFS, SMB, of course, S3 object storage, and SUSAN level protocols. Okay, and all that you can put together for better use on the free NAS appliance. Okay, let's look at the assignments that we have, and please make a note that these assignments you need to complete using free NAS. Okay, why free NAS? Because it's free. And of course, if you have any NAS box that you can make use of, please feel free to do that. But the assignments are specifically designed for a free NAS environment. Okay, let me go over those assignments quickly. The first one is the first basic assignment, where once you deploy and configure free NAS using all the knowledge that you have built throughout all the community programs so far, we need to configure your free NAS, starting with creating a volume and check if you can, list those volumes and verify that. Okay. The second assignment is to configure ICASI target share and verify if you can use that on a client. Okay, and use it for any data creation. The third assignment is, of course, an extension of what you have done so far using the NFS share. Of course, this time the NFS share or export would come from your NAS box, right? So the NFS share mounted on a Linux client, of course, uh, and now you can create few files on it and verify on the cluster side how it's get returned to the storage side. Okay. Assignment number 4 is something similar but using the SMB protocol, and for benefit of covering Windows aspect, we can map it on a Windows client. Of course, if you want to do it on a Linux box, you can always do that, but you will need a client for doing the same. And again, you can create files and verify on the cluster where those files are getting written. The fifth assignment is to perform the operations over FreeNAS appliance itself by actually connecting to it through SSH, and pass the output on the test machine to see where this data is being stored, what are the different services that are being provided, and the CLI based command line. And of course, the last part is to take a quick swipe at the performance measurement. You can do a simple performance test of NFS versus ext3, or SMB versus your Windows based file system, right? And that is NTFS, of course. And you can use any tool that you want. A couple of them I have listed here, something like an IOZone or VDPench. You need to figure those out, how exactly that can be used, and measure the IOPS for the storage system. And I think that brings us to the end of our session. Like I mentioned before, this is a logically last session that we have before our vacation coming up for Diwali over next couple of weeks. And this is a conclusion in itself, where we started our journey with Linux fundamental, then we looked at the file system aspects, right? And then we looked at different protocols, NFS, SMB, and object storage, of course. And finally, the storage fundamental, where you would get an experience to work on a NAS appliance using FreeNAS. And that's pretty much that we have from our side today. As usual, if you have any queries, reach out to us on learning@a4tech.com. Pranav, I think that's pretty much it.
Great. Thanks, Sachin. Thank you for a fantastic primer on the storage systems. And before we part for the vacations, as you said, this was our last logical session, but we'll meet the audience after the Diwali vacation. The team who is driving this will get back to all the audience on the exact dates when we are going to resume the sessions. Hopefully, that will be somewhere in the first week of November. Till then, I wish everyone a happy Diwali and happy vacations and happy learning in the meantime. Thank you.
Thank you, everyone. We'll see you after a couple of weeks. Thank you.